Well, we finally get to the last part that contains some names and matrices, which will probably also contain all the missing information for us to build this model. Let's open it. What do we have here? First, we have C8. Naturally, it could be a number of records here, but if we scroll down, this is some kind of a table, and now it changes and we have some matrices here. So this C8 is about 200. This is just too big to be a count of these records. Also, they are not fixed size like that was. We had a table of models in the beginning of UBR file. That's not like this here. It looks like names have a size of a name before it, like this 12 is a number of bytes in hex, like 12, and this 3 is 3 bytes for AMS. We can't count them by dividing. So probably we will write a small test program that will read this and until it crashes. And then we can probably find something about this. What do we read? First number, then 6 floats, probably a bounding box again. 3 more numbers, 1, 0, 2 zeros, 45. Then some name and another name. And this is probably the beginning of a second record. So we'll repeat this until it crashes. Well, I will not show this. I've written such a test program and it crashed after somewhere about here, which I could expect. And it loaded 45 records in hex. So I immediately see this 45. Probably this 45 is not the middle of the first record. Maybe this is just some ID, then the bounding box of the whole model, then 2 zeros and a count of records of some kind. So I changed that. I skipped this all, read the count, and this is the start of the first record. Name, then some number, bounding box, 3 more numbers, and that's the end. It's this first entry here. Then I exported this to a text file and opened it as a table. Let's look at that. What do we have here? First name is probably, it looks like a submesh name. We see some tires, suspension, probably doors, and probably the body of the vehicle itself. Second name is always AMS. This number, we don't know what this is. Then we have 2 equal numbers here and here. They are small. And this is a sum of all of them. I don't know what this is. And this looks like sequential numbers for all of these records. So these are probably submeshes. And it looks like this E-type, there are 80. This can be highest load because there are 6 tires and suspensions for all of them. Now for this 3, 9, that's about the same. But this, there are only tires, and in this C and D type, there is only 2 submeshes. This is probably lowest load, higher and higher, and this is the highest load. And they will be then, in this case, they will be counted from this, from the main submesh probably, and then until the last one, 45, that's the last submesh of the lowest load for this. All right, so we are currently here. This 8 is this 8, and now we are here. What is this? We have a number of matrices and some names between them, matrices again, more names, and this continues. Okay, this 6. This is probably a number of lots. 1, 2, 3, 4, 6 lots. Okay, now we probably have a list of all bones for all these lots. 6. That's a name. MS5, that's probably the lowest lot because 3 matrices here, 1, 2, 3. And then this is probably 2 names. And then AMS4 is the name of the next lot, like second from the end. Now let's go to one of the last lots. This will be more informative. Like this AMS1, probably one of the, yeah, that's second biggest lot. We have 21 matrices, I mean bones here. This is 33 in decimal. And for each bone we have a name. Now that's terminal, driver door, tires, some tube, headlight, that's effects, headlight, some spawns, effect dust, effect tail light. Okay, and in the end we have 12, some of 12 records with names again, and some numbers after each name. Now these names, as we can see, they are only the names that we have here. 12 in hex, this is 18. Like for each of these we have some kind of a number. Well, even if we didn't know that there are 6 lots here, we could identify there are 6 big records, each containing some different number of matrices or bones, each with a name. And this FFFF is probably a parent bone. Like the first bone is a root bone, it has no parent. Second will have this here, like 0. And then this is probably coordinates X, Y, and Z. And the remaining part of this is always looking like this. A couple of 1s, lots of 0s. So it looks like all these matrices are 0 rotation matrices, or maybe we don't know how exactly they represent them, because all of them are the same. If in some model we have some kind of rotations, not zero rotations, we could identify that too. So this way we have all the bones for all the lords, and 21 bone and 12 names in the end. This can be that there are only part of these bones which are actually connected to M model, and the bones such as lights and effects of different kinds, they are not connected. So these numbers 7, 6 after each of them, this is probably a bind to a submesh, because in this game all the models, they are solid, they don't have weights for different bones. Each submesh is probably just connected to one bone, and this number, this A, is a number of bone which is connected to. So after we read all these matrices, that's the last list of names here. Steering wheel will end up here. And that's again some new kind of list, which looks really similar to the first list here. And no count again, because right after this last one, steering, AMS is also in this list. No, that's not this list. Okay, steering and AMS. Anyway, AMS will be the last element here. And this 0 is for it. So this is the end of this list. We can probably parse it and build a skeleton for this vehicle, but we'll not do it right now, we'll do it later. Right now we need this list. So no count again, it just starts from some name and some numbers, 1, 1, 3A, 3EB, we've seen that somewhere. And then a bounding box again. And this 6 and 4, and that's probably our next element. So I will make another test program to pass from this here down there to see when it will crash and see what will it give us. I already have a result of that here. I call that part 3 because it's matrices are part 2, this is part 3. Let's see. This one will have a name, logo, 1, 1, 3A, 3EB, 2, 6, 4 after this bounding box. I'm not putting bounding box here. 6, 4. This is the first entry. And it crashed after 124 records. Well, actually, this is a sum of all these numbers. So it looks like, also if we look at these names, they look like materials. Blue, yellow metal, decal, window. Again, for each load. These numbers are the same numbers we've seen in that first part. So this lowest load has only 4 materials, 2 metals, 2 main AMS materials. This is always 1. This is probably a number of material inside of submesh. This last one has 8. This is a number of materials in a submesh. These are all of them. And again, this order is not sequential, like they're all messed up for some reason. And these are names for them. All right, so it looks like this part 3 is a table of materials for each submesh. And this 2 and 6, this can be these big numbers. I made a total count. This last one is 9,000 in decimal, like this many in hex. If you remember, this is a total count of vertices in our model. So this is probably a count of vertices in one particular part of a submesh that will be this material, and this is a... Okay. Well, now we have just too many numbers for this model. And this number, if we count them all, it will be... It will be very close to a count of face indices we found in our faces part. So this is probably a count of faces, count of vertices. That's normal. That's the usual table of submeshes. And as usual, it has subdivision by materials for each submesh. All right. But question is, how do we build a model from all this data? We have just too many of numbers. They are all messed up in some random order. We need to think of a way, how can we define this? And this big model of a vehicle, it was useful for defining, identifying the general structure of all these parts and submeshes and materials. And now, when we need to know exactly how do we connect the vertices and faces, we probably can take some very small model and by that example, we can understand how it's all working. But before that, we have to see where this second program crashed. And it crashed the last material is the window. 6. Now we don't have to crash it. You know, we know that the number of elements here will be a sum of these numbers here in the first table. So we can actually load all these 3 parts automatically in our tool. And after this 6, 12, 6, where are them? 6. This is a bounding box. This is 12, which is C in hex. And 6, and what do we have here? After all these materials, we have some magic numbers. 8CA. It's very close to a number of rows of those 10 bytes table. Interesting. We don't know what this table is about. But now we can understand this is its size. And this 28, it's a number of records -1 in this table. Probably this table will always have at least one record. So if I have 0 here, there will be only one record. And this BBF is just -1 of this. Remember, we didn't know exactly how many records each table has. So now we have these numbers here. We found them here. And we know exactly how to read that faces part we did in previous part of this tutorial. And now after these three numbers, we have something 1. This one is AMS again, and it has D elements, and we can pass in this further. This is some kind of CD box, and this is the end of a file. Well, it really looks similar to all this before. This may be some kind of different boxes. This looks like a matrix again. 0 rotation matrix again. But we won't do it because it will be really similar. There is nothing in the end of the file. That's probably just last entry of these D entries. So what do we have now? We passed the matrices part to the end. We found how do we find these numbers for face part. We have a table of all materials and a table of all submeshes with a count of material for each of them. And just to be sure, I made a count for each load. The lowest load will have 250 vertices in it, then 500, 1000, 2000, and highest load will have a highest number of vertices used. That's all for this part.